would have had it both be happen at the same time, it'd be more than 3 and less than -3 at the same time. Not too many numbers like that. All right. So so John, you want to just go ahead and put yours up? Can you give us the quick version? The graph? We should get Sujatha to do this all the time here.
Yeah.
She's a lot neater than I am. Are we agreeing? And the other thing that's really nice is she has, look at how nicely she has her axes labeled. Isn't that like so beautiful, you can't hardly stand it? Don't you wish everybody's looked like that? All right, we good? All right, great. So here's another one for you. Ooh, that's a good problem. Can we go 1, 2 over here? How about f of x is, I'll give you a chance to check your battery too. 2 tangent of x minus pi over 4. Is that gonna work or not?
Yep.
Okay, great. Thanks.
Great run right there. Sit down and I'll see it. What?
She's probably just gonna be there anyway. All right, so take a minute. Think about what tangent looks like. Think about what the 2 does and what the pi over 4 does. And then confer with your group mates.
So the 2 does a vertical step, and the pi over 4 does use it right pi over 4. So just this there right here.
The asteroids moved to pies. Right.
We'll move to, like this one moves to 3 pi over 4. Okay. Six that pi over 2.
Right. Okay.
So it will shift to the right. And then the asymptote is 3 pi over 4.
So the asymptotes
Or 3 pi over 2.
When it was however before, one is not
Oh,
however
no,
before
we-
two.
Yeah.
Oh, we know.
So now the asymptotes are
That's
negative
pi over 4.
negative pi over 4.
I have heard that. We have however before.
Yes.
You know, it was right. Yeah.
I'm writing down things. So you have them like all the time.
Yeah, so the however before, I think, that, not the however before. last year looks dated. Tangent, it's tan pi over 4 or 5 because tangent is
Yeah,
asymptotic.
no, it's not.
Okay,
It's gonna be like 3/4 basically.
yeah, it is. It's tangent is cosine over sine. What's the sine of 0?
Tangent is sine over
Which
cosine.
one was pilot?
Wow. Actually, I'm right.
No idea.
My God. What is
Ah, you are struggling today, Alex.
I really am. Oh my gosh. Oh. Wow. That's.
We're gonna have a point that's at pi over 2.
Seriously?
What is wrong with me? No brain, you still have 2 more days. Oh my God.
I am.
4. Is that where everybody else is going?
I'm going to Nicaragua.
So if you have point 0, 0, then you have point.
Where are you going?
And then point pi over 4, comma 1, then you have like 1/2 pi.
Oh, you're mind wonder.
Over 2. Negative pi over 4, negative 1, then you have 0, negative 2.
Yeah.
Zero.
All right, what are we thinking?
Is pi over 4?
Asymptotes what?
Shifted.
Shifted.
0, 2.
Which way?
Zero,
How much?
negative
Right.
To the right, pi over 4. So my asymptotes used to be, on the first
Right.
pair, used to be at negative pi over 2
When
and
we have pyramid.
pi over 2, so now what happens?
Pi over 4.
Pi over 4
Negative
pi over
pi
four.
over
3 pi, and 3 pi over 1.
What?
Oh, I wasn't, I'm sorry, am I doing the picture over here?
Now you're not.
All right,
Wait, can I zoom up?
all right, you got it?
I got them up, yeah.
I would hate for us to not win an Academy Award. Okay, so there are my first set of asymptotes. We'll fiddle with the rest of it in a minute. Okay, what else? Vertical stretch. So how am I gonna how am I gonna get that in there? How am I gonna know where the vertical stretch is, or how am I gonna show it? All
When
right.
it used to have like a point that was at 1, you make it 2.
So I used to have pi over 4, 1.
So now you have pi over 2, 2.
Okay, because the pi over 4 has moved to pi over 2, and it's gotta now be up at 2. What else do I need?
You did 0, -2 because it used to be negative pi over 4, -1, but now it's shifted to the right.
So I used to have negative pi over 4, -1, so that's moved over, and then stretched. So I've got that, so now I need one more point. What, no, thank you.
Pi over 4, 0.
Yep. I know, we're so busy getting the hard points, we missed the easy one. Okay? And so where does that, what happens in the next period? Tell me some numbers, some good numbers on the next period. Emma?
1 1/4 pi 0.
Okay, so that's like, so, here comes pi, here comes 5 pi over 4,
Pi -2.
so pi -2. What'd you say, 5 over 4, 5 pi over 4,
0.
0,
And 3.5 pi 2.
So 6 pi over 4, 2. 7.
Because you have an
Which
asymptote
would
at
be 3, 7.
1 3/4.
okay, so that one, and then my asymptote's at 7 pi over 4, okay, because it's a pi later from 3 pi over 4, okay. All right, we're good?
Is that 7 pi over 4 for the asymptote?
It's trying to be. Okay, does that make sense to you?
Yeah.
Alright, and so now you get to see why I cared about this point right here. Because if we didn't have this point, how would we know that we had a vertical stretch? Okay, that's the point that ends up showing us that we have a vertical stretch, because now it's up at 2 instead of being at 1. Okay? And this does indeed cross at -2. Alright? We're good? Alright.
Wait, what's the domain?
Oh, great, good question. Should we back into it? Want to do the easy stuff first? Okay, what's the period? Pi. Okay, how far do we go before our shape repeats? What's the range? All real numbers. Okay, we postponed as long as we can. Nathaniel?
Well, I started by saying, since the period is pi, you're going to have an asymptoted interval of pi, so we can say k pi at the beginning.
All right, say okay, say it. I'm sorry, I must not have been paying enough attention. Say it again.
Since the period is pi, you're going to have an asymptote every pi, so it's going to have to go up by an interval of k pi. So you start out with k pi. Then I said, the first one is at minus pi over 4. So I said k pi minus pi over 4. I could have said k pi plus 3 pi over 4 would have done the same thing.
Okay. Let's first of all see if we believe that this is right. How can I check to see if Nathaniel's right? Okay, plug in integers for k. So I put in 0, I get negative pi over 4. When I put in 1, I have pi minus pi over 4, which is 3 pi over 4.
One,
Is that written in English?
so is this what x is not equal to?
So I need
Oh, that's
wheels.
Yeah.
X is not equal to, yes ma'am. And then if I put k equals 2, what am I up to? I did 1? Yeah. Put in 2, then that would be 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. Looks like it's working out. Yes ma'am.
Never mind.
You sure?
Yeah.
Okay. Marie?
Never mind. I wrote it differently, but
Okay, how else could we write it? Anybody have an idea? Go.
I did 4k minus 1 over 4 times, all of that times pi. Which is the same.
Just the same thing. When this is 0, I'd have negative pi over 4. When k is 1, I would have 4 minus 1 is 3. When k is 2, I have 8 minus 1 is 7. Yeah, that looks like it's working out just great. Okay? We're good? All right. Well, I was going to have us go to the board for this. Oh, I know what we can do. Here's what we can do. Write me a cosine curve. Let's write a cosine function with amplitude. Oh, you don't know what amplitude is?
Yes. It's how far away from 0 it is.
Okay, height, how far away from 0? So amplitude, forgot that I hadn't told you this. Amplitude is defined to be max minus min over 2.
You did tell us that like a really long time ago.
Oh, right, went way back when we, oh yes, thank you, Uncle, I've forgotten that.
Somewhere in
Thanks a
the
bunch.
notes.
Way back when we did sine, probably way back in the day, right?
Yeah.
When we did two-dimensional function.
Yeah, we're starting, so, okay, great, thank you, Kelly. Okay, so, well, let's just talk about this then. So let's talk about the secret function. Forget what I was gonna, tell me to turn you this way, please. Forget that, we're not gonna do the other thing. Let's talk about the amplitude here. The definition of amplitude is max minus min over 2. What's the amplitude?
A regular secant?
Yeah, regular secant. Well, what's the maximum value? What's the very biggest this could ever be? What number is the very biggest this could be? Okay, and the problem with that is infinity is not a number. Bajillion? Well, then I would say bajillion and one. Okay, so this thing actually doesn't have an amplitude because there is no max and there is no min because they go on and on forever and ever. Hallelujah. Okay. So secant doesn't have an amplitude. What about cosecant? No. So go back over there where you did the toolkit version of these. What about tangent?
Nope.
Nope. Cotangent? Nope. Sine?
Yes.
Yes.
Okay, what would the amplitude of sine be?
Just regular old
Zero.
Yeah, regular old sine. What's the max?
One.
One. What's the min?
Negative one.
Over two. So
One.
it would be one, right? So the amplitude of sine is one. Amplitude of cosine? Also one. Okay. So sine and cosine have amplitude, the other guys don't. Okay. All right, let's have some homework then. Let's have some homework.
So not doing the cosine function.
Page 310, number 1, the evens. Number 2, the evens. Page 318, number 4, the odds. Okay. And I've signed a number of course selection sheets. I don't know if I've signed everybody, so I think you're supposed to have those to Mr. Reg by tomorrow, right? So let's remember to fill those out, get your signatures on whichever courses you need signatures. Thank you very much, I'll see you tomorrow. You're the one who reminds me. I need a pencil. Oh, no, I get pens. Thank you.
Pencil's no good.
Yeah,